Next type of bridge is the Kelvin double bridge. So, one important disadvantage of Wheatstone bridge is the effect of contacts and lead resistance come into the picture when it is used for the measurement of very low value of resistances. So, that disadvantages can be overcome with the help of Kelvin double bridge. So, the effect of leads and contact resistance is taken into consideration while deriving the bridge balance condition for Kelvin double bridge. So, with the help of that, the errors can be minimized. So, this Kelvin double bridge has 4 resistive arms similar to Wheatstone bridge R1, R2, R3 and Rx. The only difference between the Wheatstone bridges and Kelvin bridges is Kelvin double bridge has another set of ratio arms is A and B. So, in Wheatstone bridge we are having only one ratio arms R1 and R2. In Kelvin double bridge the ratio arm is divided into 2 sets, that is the first set is R1 and R2 and the second set of ratio arms is A and B, and the 2 junctions will be connected to a voltage source. So, I am marking these junctions as 1, 2, 3, 4, 5 and 6. So, the galvanometer is connected between the points 4 and 3. So, the Kelvin double bridge which is used for the measurement of low resistances, because the effect of lead and contact resistance is taken into account while deriving the bridge balance condition. Here Ry is taken as the lead resistance between the resistances R3 and Rx. So, the Kelvin double bridge has 2 set of ratio arms. So, the first set of ratio arms is nothing but the resistances R1 and R2, and the second set of resistance arm is nothing but A and B. So, the bridge balance condition. So, the bridge balance condition is when the resistances R3, variable resistance R3 is varied, the bridge is balanced such that the current through the galvanometer is 0, as like in Wheatstone bridge, the potential difference at the arms R2 and R3 will be equal when the galvanometer reads 0 current, because the potential at 4 and 3 will be equal when the current through the galvanometer is 0. So, at bridge balance condition, the potential across the junctions 4 and 5, which is taken as E45, will be equal to the potential across this arm, which is nothing but E513. So, along with the resistance R3, the resistance B is also considered. So, this arm has 2 resistors R3 and RB. So, I am going to consider this branch as E513. So, this is the bridge balance condition. So, at balance condition, the galvanometer reads 0 current. The only condition which is to be considered is the ratio of the resistances across A and B is same as the ratio of resistances across R1 and R2. So, the ratio of resistance across A and B must be equal to ratio of resistance across R1 and R2 in case of Kelvin double bridge. This is the condition which is to be considered. Let me take this equation as equation number 2. Next, we will find the value of E45 and E513 and we will calculate the value of unknown resistance Rx. First, to find E45, that is the potential at the difference at the points 4 and 5. So, when the galvanometer shows null deflection, that is the current through galvanometer is 0, the resistance R1 R2 will be in series. So, I am redrawing this circuit to find E45. So, R1 and R2 will be in series, which is connected across the supply E. The current through is taken as I. So, we know that E45, which is the drop across the resistance R2, E45 which will be equal to current through this resistor, which is I into the resistance R2. So, from this circuit, let me find the value of E. Here E will be equal to, V is equal to I into R. So, E is equal to I into R2 plus R1. So, from this find the value of I is equal to E divided by R2 plus R1. Now, substitute the value of I in this equation. Let me take this equation as equation number 3. So, substitute I in 3, we will get E45 is equal to E divided by R2 plus R1 into R2. So, the value of E45 is E divided by R2 plus R1 into R2. Let me take this as equation number 4. So, I want the value of potential across this resistor R2 in terms of the resistance. So, I have to find the value of E. So, to find the value of E, I am going to consider the path 5, 1, 2, 6 and again 5. So, I am going to redraw the circuit. To find the value of E, I am going to consider the resistance R3, resistance is BA, and the contact resistance is taken here, which is RY, and Rx, which is connected across the voltage source E. Now, R3, 5, this node is 1, 2, this node is 6. Now, let me consider the equivalent resistance between the points 1 and 2 as the equivalent resistance is taken as R12, that is between 1 and 2, the value of resistance is R12. So, what will be the value of R12? Here Ry and the resistance A and B are connected in parallel and the resistance B and A are in series. So, if you find the value of R12, it will be equal to Ry into A plus B divided by Ry plus A plus B. Okay. The value of R12 is equal to Ry into A plus B divided by Ry plus A plus B. Now, if I write the voltage equation for this circuit, I will get E is equal to, the current through the circuit is taken as I. So, I into R3 plus this resistance R12 plus the resistance Rx. So, I am going to substitute the value of R12 here. I will get R3 plus Ry into A plus B divided by Ry plus A plus B plus Rx. Let me take this equation as equation number 5. Now, I am going to substitute the equation number 5, that is the value of E, in equation number 4. Equation number 4, E45 is equal to E into R2 divided by R1 plus R2. So, I am going to substitute the value of E from equation 5. So, I will get R2 into I divided by R1 plus R2 into R3 plus Rx plus Ry into A plus B divided by Ry plus A plus B. So, this is the equation for E45. Now, I have calculated the value of the potential across a resistor R2, which is E45, which is R2 into I divided by R1 plus R2 into R3 plus Rx plus Ry into A plus B divided by Ry plus A plus B. Next, I have to find the value of E513, that is potential at the nodes 5, 1, 3. So, for this, I am going to consider the path 5 to 2 in the original circuit. I am going to draw the circuit from 5 to 2. I have the resistor R3 and the two resistors which are connected in series and parallel, that is B, A and Ry. So, this node is 5, this is 1 and this is 2. So, I already have considered the equivalent resistance between 1 and 2 as R12. Now, I am going to take the voltage drop across this node 1 and 2 as V12. So, the drop across 1 and 2 is taken as V12. So, in order to find E513, I need the potential difference from 5 to 3. So, 3 is nothing but the point between the resistances A and B. So, I need the potential from 5 to 3. So, the drop across R3 can be considered, but in this circuit I need only the drop across this resistor B. So, I am going to take this drop across this resistor B as V13 since B is connected between the points 1 and 3. So, I am going to consider this drop across this resistor B as V13. So, from this circuit E513 will be equal to the current flowing through this circuit can be taken as I. So, it will be equal to I into R3 plus V13. I need only V13. So, I have to calculate the value of V13. So, before calculating the value of V13, let me find the value of V12, which is the voltage drop between the points 1 and 2. So, V12 will be equal to the current through the circuit I into the equivalent resistance of this circuit, that is between 1 and 2, that is R12. Already we have found the value of R12, which is nothing but I into Ry into A plus B divided by Ry plus A plus B. Let me take this equation as equation number 6. So, I have found the value of V12. I am going to redraw this circuit. So, V12 is the drop across this between these junctions 1 and 2. So, V12 which is connected across the two parallel resistors Ry and A and B, that is B, A and Ry. So, the current is taken as I, the drop across B is taken as V13. So, from this circuit I need the value of this V13. So, by applying voltage division I will get V13 will be equal to the total voltage into the resistance B divided by the sum of resistance. So, let me take this equation as equation number 7 and this is equation number 8. So, the value of V13 equal to V12 into B divided by A plus B by applying voltage division technique to this circuit, right. So, let me find the value of I. We know that I is equal to V12 divided by A plus B. So, current through this branch is taken as V12 divided by A plus B since these are connected in parallel. So, the value of V12 will be V12 divided by A plus B. So, value of V12 will be equal to I into value of V13 will be the drop across the resistor B. So, V13 will be equal to I into B, the current through the resistor B. So, it is I into B. So, the value of resistance I V13 is equal to I into B. So, now substitute, take this as equation number 8. Now, substitute the value of V12 from here, substitute 7 in equation number 8. So, I will get V13 as I B divided by A plus B into Ry into A plus B divided by Ry plus A plus B. Let me take this equation as equation number 9. Now, substitute the value of V13, that is equation number 9 in this equation E513. So, substitute 9 in the equation E513, I will get E513 is equal to I into R3 plus I into B by A plus B into Ry into A plus B divided by Ry plus A plus B. Now, let me take this equation as equation number 10. So, I have calculated the value of E45 and E513. So, at balance condition, the value of E45 is equal to E513. So, I am going to equate the equations 6 and 10. So, equating 6 and 10, the value of E45 is I into R2 divided by R1 plus R2 into R3 plus Rx plus Ry into A plus B divided by Ry plus A plus B. This is from equation 6, and from equation 10 I will get the value of E513 as I into R3 plus B divided by A plus B into Ry into A plus B divided by Ry plus A plus B. So the current II gets cancelled, and also A plus B and A plus B will get cancelled. I am moving this term to the right hand side, so I will get R3 plus Rx plus Ry into A plus B divided by Ry plus A plus B is equal to R1 plus R2 divided by R2 into R3 plus B Ry divided by Ry plus A plus B. So I am going to rearrange this equation. So the left hand side remains same, R3 plus Rx into Ry to A plus B divided by Ry plus A plus B is equal to 1 plus R1 by R2 into R3 plus B Ry divided by Ry plus A plus B. So I am going to remove this bracket. So the left hand side remains same. Ry plus A plus B will be equal to R3 plus B into Ry divided by Ry plus A plus B plus R1 R3 by R2 plus R1 B Ry divided by R2 into Ry plus A plus B. So R3 will get cancelled. So I am going to move this term to the right hand side. So I will get Rx equal to B, that is R1 R3 by R2 plus B Ry divided by Ry plus A plus B plus R1 B Ry divided by R2 into Ry plus A plus B minus this term Ry into A plus B divided by Ry plus A plus B. So Rx will be equal to R1 R3 divided by R2 plus B Ry divided by Ry plus A plus B plus R1 B Ry divided by R2 into Ry plus A plus B minus I am going to remove the bracket. So I will get Ry A divided by Ry plus A plus B minus Ry B divided by Ry plus A plus B. So B Ry plus these two terms will get cancelled. So by taking the common terms out, R1 R3 by R2 plus Ry divided by Ry plus A plus B will be equal to, I am taking Ry divided by Ry plus A plus B as common term. So I will get R1 by R2 minus A by B. So the first condition in the Kelvin double bridge is the two set of ratio arms values must be equal. So in Wheatstone bridge we know that the ratio of R1 and R2 is equal to A by B. So the R1 by R2 minus A by B gives the value as 0. So the value of Rx is equal to R3 into R1 by R2. This is the bridge balance condition for Kelvin double bridge. So this equation shows, this equation is nothing but the standard bridge balance condition for Wheatstone bridge. So this is same as Wheatstone bridge. So the effect of lead resistance Ry and contact resistance are completely eliminated in the bridge balance condition. So in Kelvin double bridge the effect of contact and lead resistance is eliminated by using a second set of ratio arms A and B, and the bridge balance equation will not get affected because of that any contact resistance or lead resistances. So the resistances A, B and Ry are not in this output, that is unknown resistance bridge balance equation. So the important condition for bridge balance condition is the set of ratio arms R1 and R2, A and B value must be same. So the range of resistance which can be measured using Kelvin double bridges from 1 ohm to 1 micro ohm. So the resistance of value less than 1 ohm up to 1 micro ohm can be easily measured with the help of Kelvin double bridge. If Wheatstone bridge is used for measurement of this low value of resistance, the effect of contact resistance will affect the unknown measure resistance value. So the accuracy of Kelvin double bridges from plus or minus 0.5 to plus or minus 0.2%. So the accuracy of the Kelvin double bridges from plus or minus 0.5 to plus or minus 0.2%. So the Kelvin bridge is used for measurement of resistance, that is low resistances, that is from 1 ohm to 1 micro ohm. So in today's class we have seen what is a bridge, how the bridges are used for the measurement of resistances, and what are the types of bridges used for the measurement of medium and low value of resistance. Thank you.